Our mission today is to print 8 walls in less than 8 hours. The purpose of this research is to see how these walls will behave in situations like earthquakes or strong winds. Printera has partnered with Carleton University, Dr. Bahid, and PhD candidate Morteza to be able to print these 8 concrete walls that later on they will be tested on their cycling lateral load. Our first duty of the day is to prepare our printer. We make sure to properly connect every hose and make sure there is no obstruction for the printer.
One sec, wait.
The tools may evolve, but the principles endure. We are mimicking masonry construction. Our foundation block will be later connected to our walls to transfer the loads from the bond beam all the way to the ground. Our concrete has 3 phases. The first one is the flowable phase, which allows the printer to pump concrete into the nozzle. After 7 minutes, the concrete reaches the plastic phase, where the concrete is strong enough to receive a layer on top. And after 30 minutes, we reach the hardened phase, where the concrete is completely dry and is impossible to modify. We lay the first layer of all the 8 walls at 180 millimeters per second. By the time the loop finishes, the starting point has reached the plastic phase and is ready to receive the second layer. That's what we call setting time. Although the whole printing process is automated, we still need to make sure to supply the materials for the machine to mix in concrete.
Hi, my name is Jason from Printera. I'm the material specialist. This is our batch plant here. I operate the batch plant. So we have all the material here to make our concrete. So we have our fine aggregate, which is our sand, coarse aggregate, which is our stone. We have our cement here, which gets fed into our mixer. This right here mixes the concrete. All the material goes in through here. Once we put our fine aggregate, coarse aggregate, and our cement, we have some other special stuff that we put in, like fibers and super plasticizer or plasticizer. And what's special about our concrete is that once we print, about half an hour later, our concrete is dry enough that we can pick it up, move it, and continue printing.
Every project starts on a computer. We design our 3D models and export the G-code that tells the printer how to build it.
I'm Sukhman, and this is our 3D printed concrete. We printed this all in one day. So the 3D printer is completely automated. I programmed the G-code, and the printer does basically everything else. All I do is monitor and change certain variables to make sure the print is running smoothly. Our printer can move up to 250 millimeters per second. In just one day, it's about 4 cubic meters of concrete. This was only done because of the great coordination between our team, from the batch plant to the pump to the printer. And we got to make sure that the concrete is coming out consistently, and that's a big effort between all of us in making sure that we communicate correctly, changing certain chemicals and variables to make sure it's a successful print.
To track the behavior of the walls, PhD candidate Morteza Mahamadi is installing strain gauges into the rebar. These sensors will measure how much steel stresses under load. Take a closer look at our wall design, and you will notice 2 key components. The first one is a structural webbing, which acts like a concrete masonry unit, and will have the vertical reinforcement. The second one is the insulation cavity, which will give us the thermal performance, or R value, essential for the Canadian building standard. Construction in Canada faces a labor shortage. Population growth outpaces housing supply, and the labor is not meeting the demand. 3D concrete printing could be a solution. We can build faster with smaller teams and without harming the quality of construction. Right now, there's no official building code for 3D concrete structures in Canada, but the National Building Code allows for alternative solutions as long as we can prove the performance. Innovation doesn't happen by accident. It needs to be built, tested, and proven. And that's exactly what we're doing here in our Research and Development Department, bringing 3D printing construction into our reality.